Melbourne Primary School, maths instruction follows the curriculum scope and sequence. We use pre and post assessments from Essential Assessment to guide our planning and ensure lessons target the needs of students. Applied tasks provide opportunities for students to put their learning into practice. They allow students to make connections between mathematical concepts and real-world situations, strengthening their understanding through problem solving and reasoning. Blitzmaster has contributed to measurable growth, improving automaticity across all year levels. In our junior classrooms, students are exposed to the problem-solving strategies right from the beginning of the year. The problem-solving wheel is displayed in each classroom and referred to during maths lessons. Explicit teaching of these strategies happens early on. We're able to see here some prep students who are already implementing these different strategies, drawing a picture, using materials to model their solutions, and thinking out loud is really clear and evident when listening to these students problem solve. They've already got strategies which help them to count more efficiently, use different number sentences when needed, and are able to explain their thinking because of the way they have already developed their problem-solving skills.
15 buttons are shared equally between 3 people. How many buttons will each person get? So I drew a picture of how many buttons each person gets, and I chose this because it will make it equal and I don't have to count it over again.
As students progress through the year levels, their ability to apply a range of problem-solving strategies continues to develop. Through ongoing explicit teaching, these skills become more refined and we begin to see deeper mathematical discussions and clearer reasoning within our classroom. Our problem-solving strategy wheel remains a key feature of maths lessons across the school. In Grade 3, we see the inclusion of new strategies in the wheel, ready for our students to master. At the start of each math lesson, students begin with a warm-up question designed to get them thinking and applying what they've learned in previous lessons. These questions are carefully chosen to make us use the spacing effect, giving students the chance to revisit and consolidate concepts taught in previous terms. During this time, students are encouraged to apply a range of problem-solving strategies to approach the task in front of them, before sharing and discussing their thinking. In the back of their books, students keep a copy of the problem-solving wheel, which they use as an accountability tracker to track which strategies they're using most. This helps them reflect on the approaches they tend to rely on, identify strategies they might overlook, and recognise areas they could strengthen. Over time, this reflection supports them in developing greater flexibility and confidence when tackling new or more complex problems.
In the upper primary area, the problem-solving wheel is explicitly taught in the first 2 weeks of Term 1. We choose 2 strategies each lesson and design mini-lessons where we model using the specific strategies, and then the students are provided with questions designed around those strategies. At the end of the 2-week mini-unit, students are given a number of problems to solve. It is up to the students to choose which strategy they employ to solve these questions. Students work in pairs and small groups. This is beneficial to encourage them to explain their thinking and the steps that they follow to solve the problems. The problem-solving strategies are integrated throughout maths. The wheels are displayed in every classroom as part of the maths wall. Students have a copy glued into their workbooks, and as part of the warm-ups, potential strategies are discussed before students are sent off to work. Students share back which strategies they used to get their final answer. They are then expected to reflect on which strategies they used during the lesson.
I got it. Jesus. I got it though.
What are some different problem-solving strategies we could use to solve this problem? No.
Guess and check.
You can guess and check, definitely. How are you going to do it? Are you going to draw it out? Are you going to...
Draw it out and then kind of like put it on an angle and then realise we use 3 or more.
So you're going to keep drawing maybe with a whiteboard to whiteboard marker and draw out your 10 circles and then try it that way?
Yeah.
That's one way. How else can we do it? Check for a pattern. Pattern might we be looking for?
Oh.
Not sure. How else could we use it? I've got a pretty obvious hint up the front.
Yes, I know it. Please.
Lexus. Counters, which would be making a model. Is that what you're going to say, Noah?
Yes.
Sorry. Make a model. Set up, I've counted out 10 counters. Set up your counters this way and then try, like you were saying, guess and check. Try different ways by using only, how many moves can we use?
3.
Only 3. So if you do it, you can't get it, but you can do it in 4 or 5. That's not going to cut the mustard. You need to figure out a way to do it in 3 moves. Now, I'm going to give you 10 minutes, maybe not too much longer. You can work by yourself or with your friend.
You just do this.
2, 3. Does it look like the other version? Get in position, eh? Go for it.
Go here.
Mm-hmm. 2.
Right.
3. Does it look like position B? No.
1, 2, 3.
That works. Well done. That's different to my solution too.
1.
No, you can only move 3 counters. Not 3 moves, 3 counters. I like your thinking. Difficult problem in maths.
I use guess and check to either estimate what I think it will be, or if it is that, then I'll just work out the question.
Right.
If it's like multi-choice, I'll try to eliminate 2, and then like I'll try to like work out. Oh, since there's only got 2 left, and the other 2 can't be close. Just use those 2, and then I try to like work out those ones.
Okay.
And if I can't do that, I look at our problem-solving wheel in my classroom, and I try to see if I can use a different strategy.
Okay.
Well, it depends on the question. If it's like a pattern, you can like use look for the patterns. If it's like a word of a question, you can only look for the key important information.
Okay.
Yes.
Yeah? Why is that?
Because it helps me when I don't know other strategies to use. So then when I go to the strategy wheel, I find different strategies to use.
Right.
Yeah, because it like helps you if you're like struggling on like a question, or like if you like don't like know like at all, like it can tell you like new strategies you can use.
Right. Awesome. Excellent. Thank you, Isaiah. A better mathematician?
It has, because sometimes I would like think of the keywords or like what to do before like you guess. So then like you can have an educated guess and see if it's that, or because like I used to guess a random number and see if it was that.
Right. Awesome. The benefits of teaching explicit problem-solving strategies from prep to grade 6 are: it improves understanding. Teaching strategies like drawing diagrams, working backwards, or identifying patterns help students approach problems systematically, deepening conceptual understanding rather than just relying on guesswork. It builds confidence. Students become more confident in tackling unfamiliar problems because they have a toolkit of methods to apply, reducing math anxiety. It encourages logical thinking. Structured strategies develop reasoning skills, allowing students to break problems into manageable steps and justify their solutions. It promotes transferable skills. Strategies learned in one context can often be adapted to solve problems in other areas of maths. It supports differentiation. Explicit strategies provide scaffolding for struggling learners while offering advanced learners opportunities to refine and adapt techniques creatively. It develops independence. Over time, students internalise their strategies, enabling them to tackle problems independently and recognise when to use different approaches. And finally, it enhances reflection. It encourages students to select and evaluate strategies that foster metacognition, helping them to reflect on what worked and why.